Hello. This is our end of semester wrap up presentation. We developed the Automato 4200. I'm William Anderson.
I'm Mark Berglund.
I'm Isaac Franklin.
And I'm Aiden Stefan.
So, as an introduction to our project, the prototype developed is a demonstration piece for the capability of a fully automated greenhouse. This includes the following capabilities being temperature regulation, humidity regulation, water regulation, and light level regulation. All of these necessary to grow seedlings from seeds all the way to sprouts. So we integrated a lot of influences from our customer interviews, though it was difficult to pull information from every single one that was relevant to a single topic, since we interviewed such a wide base of people. From the interviews, the main objectives were shown to be limiting expense and saving time. Thus, the design should be inexpensive and reduce labor and costs. The Automato 4200 grows seedlings so they don't need to be purchased, reducing costs, and can produce fodder, which is used as a feed alternative by growing barley to produce sprouts, which also works to decrease feed prices.
Automated greenhouse systems are known for being very expensive and high maintenance. They require regular checkups and lots of work to get started. Our system is a small scale version of what we'd like to eventually implement on a larger scale greenhouse farms. However, we are approaching it from the stance of seedling growth. Once installed, our Automato system will control all environmental components necessary for plant growth. It is a modular system that can meet the needs of anyone from backyard hobbyists to large scale producers of exotic plants. So what kind of sets us apart when looking at the Automato 4200? We can see that other systems are not advertised for being easily modified for whatever plant life you wish to grow. Usually you would install a greenhouse and build it with the intention of growing a particular crop. But our model allows a wide variety of plant life with just minor modifications to the control system settings based on customer needs. Another component is cost efficiency. When compared to other automated greenhouse systems, our product is extremely inexpensive. Other systems range from $600 to $2,000 for just the controller, which does not take into account the hardware that needs to be installed depending on the greenhouse size. Lastly, our system is fully modular, which allows us to meet the need of a wide variety of clients without the extra expense of engineering specifically for the individual customer needs. They can just change the settings themselves. So what you see here is largely for the purpose of our own prototyping and proof of concept. There were several complex mechanical parts that needed to be printed, but these would be replaced in our system by existing products that can be purchased in bulk. For more simple shapes, we used acrylic parts for a clean finish and a finalized look. And on the more technical side of things, we had to bypass a high voltage source. So we mechanically flipped a switch to our light switch. We used a stepper motor to do this, and we also used a stepper motor to control the vents. DC motors were used to control the fan speed and pump. These components are used to control humidity, temperature, and soil moisture of the Automato.
At the heart of our system is an Arduino Mega microcontroller that serves as the main brains of everything. This is controlled via inputs through our user interface, which employs an Arduino LCD screen and a combination of potentiometers and switches. The potentiometers allow for fine-grained control over the input settings for each different environmental variable, and we also have an on-off switch, a kill switch, and a switch that allows for easy toggling between different unit systems to allow for easy use in many different countries. There were a number of problems that we encountered when we initially started working on this project. One of the first ones was, like Isaac touched on, our high voltage limitations, because Dr. S did not want us cutting apart wires and electrocuting ourselves with wall power. So, like he said, we circumvented that by manually flipping a switch with a stepper motor. Another big challenge was the breadboard Arduino interface. In the picture on the right, you can see our initial configuration, which was very clean and compact, but also made troubleshooting very difficult, and it made it hard to tell exactly which wire was connected where. We overcame this by recreating some of our Arduino input attachments with longer wires. Finally, one of our last challenges and most recent challenges was servo control. because the servos proved not only quite an interesting coding challenge to get all of the inputs in the right order and everything working that way, but also took a lot of fine tuning in order to get them to spin the right speed and direction and angle amount to make our features work the way we intended. Our current cost is about $170 a unit. However, as with any prototype, this is significantly higher than what it could be. Our estimates place our final cost at somewhere around $60 a unit. This reduction would come from ordering parts in bulk, ordering them from lower cost sources, and having a more streamlined approach to how everything would go together and knowing exactly which parts we need.
We settled on this design specifically because of a few key features, namely the potentiometer controls, watering system, lighting, air control, and the sensors to match. The potentiometer each control one factor of the system. We control the soil's moisture value using a combination of tubes, reservoir, and pump, all activated once our soil moisture sensor reads below a value set by the user. The light value of the environment is maintained by a grow light on the top. If the room our device is located within is dark, the system will automatically turn the light on. Humidity and temperature are controlled by a fan mounted on the roof, which will turn on or off when called upon. In conclusion, our product is designed to give you any plant you want, grown hands-free from the convenience of your desktop. This device is a fully self-contained system, allowing for the perfect control of environmental factors affecting plant health. Our convenient and user-friendly interface allows you to have precise control with the simple turn of a knob. This device is cost-effective as well, costing merely $60 a unit. If we were to continue developing this prototype, we would need to provide a way of increasing the environment's heat and directly control the light. The heat is currently a byproduct of the light, but is not controlled independently. This is dangerous because multiple aspects of the system are influenced by the same control element. This would lead to imprecision and potentially damaging the plants. A separate heating element would allow for more precise control. The grow light itself is indirectly controlled via the stepper motor flipping a switch instead of electronically with a relay. This is a workaround since, as we said, we cannot deal with high voltage since we are merely students. In the final model, everything would be controlled electronically.
Thank you for listening to our presentation, and hopefully you would like to purchase our product.